Hi there, Mr. Sutton here with the IM3 Honors Chapter 5 Quiz 2 Extra Practice Number 1 Solutions on Graphs of Polynomials and Binomial Expansion. To sketch this graph, let's start by getting our roots, our x-intercepts. That's going to be whatever zeroes out all these parentheses here. So we've got 2 for that first one, because 2 minus 2 equals 0, followed by 3, -1, and -7. So graphing those out, from left to right, we've got -7 is on the far left here, and -1's a bit closer to the y-axis. Over on the right side of the y-axis, we have 2, and somewhere to the right of that, we have 3. Okay, so let's also get our y-intercept. To get that, we just plug in 0 for all the x's and see what's left over. So that really is giving us a -2 times a -3 times a 1 times a 7, if you zero out all those x's and multiply. So that's, let's see, +6 times 1 is 6 times 7 is 42. So 42, that's somewhere up here above the x-axis. And now we have to find the end behavior. To do that, we multiply all the x's together, basically to figure out what the lead term would be if I put this back in standard form, because the lead term, the degree of that, tells us our end behavior. So we have an x times an x times an x times an x, so 4 of those. That's x to the 4th. In general, this is a positive x to an even power. So the positive is important, and so is the even exponent. That tells us this is behaving like an x squared, like an upward opening parabola, so that we are starting above the x-axis and ending above the x-axis. Next, let's get the individual root behavior, and we find that by looking at the exponents on all our factors. So all of these roots are coming from single power factors. So since these are all singles, that means that for all roots, we are going to cross through just like a line would cross through the x-axis. If those had been doubles, then we would have bounced. If those had been triple powers, we would have flattened. Since they're all single powers, we cross. So starting above the x-axis, we cross through -7, come down here, cross through -1, go through the y-intercept, cross through 2, come back, cross through 3, and we end up above the x-axis just like the end behavior says we should. To graph this polynomial, we need to start by getting the roots, which means we're going to need to factor this so we can actually find the roots. So trying to factor this, it looks like I can take out a common factor of an x squared, since all these have at least x squared. We can also take out a -2. So if I take out -2x squared, my first term is going to be an x squared, which is nice. Then we have a -6x, followed by a +9. And I can factor this stuff inside a little bit more. Factors of 9 that add up to -6, well, 1 and 9 doesn't do it, but 3 and 3 does. -3 and -3. So I can actually turn this into x minus 3 squared. And now my roots here, for the 2x squared, that's going to be a root of 0. And for this parentheses, that's a double root of 3. These are actually both double roots. So we have 0 right here on the origin, and 3 somewhere over here to the right. And now for the y-intercept, well, that's the 0 constant that's at the end here that you would get if you just plugged in 0 for all the x's. So that's 0, but that's not a surprise because, well, we had the origin here. So that's both a y and an x-intercept. It's on both axes. Now for the end behavior, we look at the lead term, this -2x to the 4th. This is a -x to an even power out in front here. That tells us that this is going to behave like an upside down parabola, like a -x squared. So we're starting below the x-axis and ending below the x-axis. Now in terms of our root behavior, these are both double roots at 0 and 3 because they came from these squared factors. That means we're going to bounce at both of those. So now putting it all together, we're starting below the x-axis. We are bouncing at 0, coming down, coming back up, bouncing at 3, and that means we're also ending below the x-axis, which is what our end behavior said we would be doing. To write the possible equation for this polynomial, let's start with the overall sign. Since we are going down as we move to the right, that tells us the function is negative, so I'm going to write y equals negative, and now we'll fill in the rest of the factors. So going from left to right, since negative 7 is a root, we have a factor of x minus negative 7, or x plus 7. And since it's crossing, that's a single root, single factor. So we just have x plus 7 with an invisible first power here. Since we're crossing through negative 2, that gives us an x plus 2, again to the first power. And since we are bouncing at positive 2, well, now that's going to be an x minus 2, and that's going to be a squared factor since we're bouncing. And that's all we had to do there. On this problem, we're being asked to write the specific equation for this polynomial graph. So we're going to start with a possible equation, and then we're going to use this point at 0, negative 18 to narrow things down a little bit more. But I'm going to start with something that has an a out in front, just to kind of represent a mystery constant that we have to find. So looking at my overall sign of my graph, since we are going down as we move to the right, that tells me that this is a negative polynomial. So I'm going to start by writing y equals negative a. There we go, negative a. And now I'm going to write down all the factors that go with that. Since we're crossing through negative 1, that gives me a factor of x plus 1. And the crossing means it's a single power factor, first power. Since we're bouncing at 3, we have a factor of x minus 3 squared. Squared because we're bouncing. And now to find the actual a value, I need to plug in this point for x and y. So we have a y value of negative 18, plugging in 0 for all the x's. So I have negative a times 0 plus 1 times 0 minus 3 squared. Cleaning stuff up on the right, this is really 1 times 9 times negative a, so negative 9a. Dividing by negative 9, we see that a equals 2. And then plugging that back in, we can rewrite this as y equals negative 2, parentheses x plus 1, parentheses x minus 3 squared. For this problem, I'm trying to expand this binomial, being raised to the third power. To help me out, I'm going to use Pascal's triangle down to 3 levels to get a shortcut formula for this. So here's level 0, and level 1 is just 1 and 1. At level 2, we got 1, 2, and 1. And at level 3, we've got 1, 3, 3, and 1. These are the coefficients of my a and b formula. So this is 1a to the third power, b to the 0, which we don't have to write the b to the 0. This is 3a squared, b to the first, plus 3a to the first, b to the second, plus 1, a to the 0, which I don't have to write, b to the third. A is going to be this 9x part of my binomial, and b is going to be the 4 here. So for this first term, I've got 9x quantity cubed, plus we've got 3 9x quantity squared times 4. Then we have 3 times 9x times 4 squared. And finally, we have plus a 4 cubed. Going through and simplifying all this, 9x to the third, well, let's see here. I have to cube each of these. What's 9 cubed? 9 times 9 is 81. 81 times 9, I believe that's 729. So 729x cubed. But I could use a calculator here if I needed to. And then we've got 3 times 9 squared times 4. I think I'll use a calculator for that. So 3 times 9 squared times 4, grand total of 972 with an x squared thrown in. And then we have 3 times 9 times 4 squared with an x. Again, let me use my calculator. There's no point in trying to do it in my head and getting it wrong if I'm allowed to use a calculator. All right, that's 432 with an x. And then finally, 4 cubed, I know that's 64, so we're good to go. For this one, I want to raise x minus 12 to the 4th power, so I can use Pascal's triangle at level 4 to get a shortcut formula for this 4th power expansion. Here's level 0. Level 1, we've got 1 and 1. At level 2, we've got 1, 2, and 1. Level 3, we've got 1, 3, 3, and 1, and I need all these lower levels to get the next level here. We've got, for level 4, 1, 4, 6, 4, and 1. So these are the coefficients of my AB shortcut formula that I'm going to use. This is 1a to the 4th, b to the 0, and I don't have to write b to the 0. We have plus 4a cubed, b to the 1st, plus 6a squared, b squared, plus 4, a to the 1st, b to the 3rd, plus 1, a to the 0, which I don't write, b to the fourth. In this setup, we've got an a value of x, and then this negative 12, that whole negative 12 there, is the b value. So for a to the fourth, we've got x to the fourth. The next term is 4x cubed times negative 12. Then we have 6x squared negative 12 squared, followed by 4x negative 12 cubed, and finally we have negative 12 to the fourth being added at the end there. All right, so we've got x to the fourth, and let's see here, 4 times negative 12, that's negative 48 with an x cubed. Negative 12 squared is 144, but I'm not sure what 6 times that is, so let me go to the calculator. So 6 times 144 gives me 864, and it looks like that's going to be positive because I had an even exponent on that negative there. So 864, and we have an x squared in there as well. Next, we have 4 times negative 12 cubed. Let me go back to the calculator for that. I have no idea what that is. Let's see here. It's going to come out negative, though, so let me just do 4 times 12 to the third power. And this is going to be negative 6,912, and we have an x to go with that. And then finally, next one's going to be positive. Even power gives me a positive, but I still don't know what 12 to the fourth is. So let me do that to the fourth power on the calculator. 20,736. I will take their word for it. So there is our fully expanded binomial.